Mission planning is a crucial step before engaging in any operation. While the tools, procedures, and technical expertise required for each operation vary based on resource type and mission complexity, core concepts of the mission planning process always apply. Effective mission planning promotes efficient mobilization and enhances safety margins across a variety of mission profiles. Mission planning considerations for aerial delivered firefighters include IRPG briefing checklist components, weight limitations and performance considerations, fuel and time management, flight following responsibilities, logistical considerations, risk management. The following scenario provides a specific example of how a Rappel module might approach mission planning for initial attack during a pre-position assignment away from their home unit. The scenario is viewed through the lens of a helicopter Rappel spotter, the module leader. A helicopter Rappel module from Idaho has arrived on the Dixie National Forest in southern Utah and is stationed at the Cedar City Air Tanker Base. A spotter's first step is to check in with the hosting dispatch, in this scenario, Color Country Dispatch, as they will be the primary point of contact for all missions and a key resource for gaining intel. Next, the in-brief with local fire and aviation management provides the crew with current fire, weather, and fuel situation, maps, radio frequencies, flight hazards, wilderness concerns, and suppression strategies for the primary response area. Through this initial contact, the Rappel module obtains local knowledge, intent for initial attack protocols, and management expectations. The crew puts information from the briefing into action. They program handheld and helicopter radios with response area frequencies and download digital map resources onto their devices. Communications and navigation information are essential components of crew safety, fire operations, and logistical considerations. Meanwhile, the spotter and pilot consider information from the briefing to evaluate aircraft capabilities and response range. They consider the daily weather forecast, departure location elevation, and potential response area elevations to complete helicopter load calculations. The load calculation determines the allowable payload for the helicopter. Multiple load calculations are completed daily to ensure safe operations within different temperature and elevation bands. The spotter then provides a comprehensive operational briefing to the rappellers and pilot, covering the situation, potential mission profiles, communications, service and support, and risk management considerations. Alternate fuel locations and predetermined landing areas are provided during the briefing, including adjacent airports, airstrips, helispots, and helibases. The initial attack and medical loads for the operational shift are identified, and interagency helicopter passenger and cargo manifests are completed. As part of the risk management process, the pilot, spotter, IC, and base manager participate in a general assessment of risk, GAR, based on known information. The GAR model allows for time-critical risk assessment and generates discussions surrounding the risk for each proposed mission. The discussion identifies potential risks and the appropriate mitigations. The GAR creates a go, no-go decision tool for each team member. Individual scores are compiled on the risk assessment worksheet, reviewed, and discussed by all members of the team. If there are any mitigations, they are documented on the worksheet. Risk management is a continuum, and additional GARs should be completed as situations and conditions change. The aircraft dispatcher calls the spotter with a dispatch via phone. The dispatcher also emails an aircraft dispatch form, which includes coordinates for the reported incident, assigned radio frequencies, including air-to-air, air-to-ground, and command, aerial hazards in the area, such as high-tension power lines, and additional resources responding. The first load of rappellers begins to gear up. The spotter and pilot formulate their flight path from the departure point to the incident by inputting the incident coordinates into a GPS or application such as ForeFlight. Information from the flight legs such as distance and direction helps determine flight time to the incident, fuel burn, alternative airports and fuel locations, where the fuel service vehicle and crew can stage if additional support is requested. The ForeFlight application offers additional capabilities to continually assess the situation, mitigate risk, and assist in mission planning. Weather radar layers display increment weather along the flight route or approaching the incident area. A hazard advisor layer identifies areas of thick smoke or low ceilings at selected altitudes along the flight route, which may be especially useful in mountainous terrain. Topographic map layers provide additional situational awareness. Elevation information allows the pilot and spotter to cross-reference incident elevation with the helicopter load calculation to validate that aircraft performance is adequate for the mission. Terrain information influences the flight route, especially when crossing high elevation ranges en route to an incident. Additionally, multiple layers may be overlaid to display visibility, topography, hazards, airspace, and other points of interest on the same screen without having to swap back and forth between maps. The spotter briefs the initial attack load, and the load completes their buddy checks prior to takeoff.
Thank you.
Anytime a helicopter and crew launch for an incident, they must establish communication with the dispatch center and initiate flight following protocols. This involves informing the dispatcher of call sign, departure location, number of people on board, fuel on board in hours, estimated time en route, destination, automated flight following confirmation. The aircraft may cross multiple dispatch zones while en route to an incident. Communication with each dispatch center is required upon entering their response area. Upon arrival to the incident area, other communication responsibilities include radio calls in the blind 12 nautical miles out from the fire traffic area, FTA, to establish contact with other aviation resources. Holding at 7 nautical miles until granted clearance to enter the FTA if an aviation resource is already on scene. These communication protocols are essential to mitigating risk, managing airspace, and ensuring positive outcomes. The first aircraft on scene of an incident will manage the FTA and clear in other aviation resources. When the Rappel platform is first on scene, the pilot manages the fire traffic area and orbits the incident, while the spotter conducts an aerial size-up and communicates this initial size-up to dispatch. The initial scene size-up includes updated fire coordinates, estimated size, fire characteristics, fuels burning in, adjacent fuels, spread potential, values at risk, estimated number of personnel to control, and any other information critical to the mission, such as additional resources needed to meet management objectives. Dispatch informs the spotter that the duty officer would like to staff the incident with rappellers. The IC and spotter work together to identify hazards, escape routes, and safety zones. They discuss predicted logistical needs and order them through dispatch. Ingress-egress routes are scouted from the air and relayed to dispatch and responding ground resources. The spotter and pilot identify the primary rappel site, emergency rappel site, and cargo site for rappel operations. The spotter confirms with the pilot that aircraft performance is sufficient for the operation. Upon accepting the mission, the spotter informs dispatch of commencing rappel operations and directs the rappellers to disconnect from the cockpit communications. Rappel operations utilize hand signals between the spotter and each rappeller for each procedure. Additionally, the spotter and pilot conduct a verbal challenge and response communication sequence for each procedure. Upon completion of rappel operations, the IC establishes communication with the dispatch center via handheld radio. The spotter, still within the cockpit, reconfigures for cargo letdown operations. Once the cargo safely reaches the ground, the rappellers verify with the spotter that they have established communication with dispatch. The spotter and helicopter depart the area back to Cedar City to prepare for other missions. The IC transmits a complete fire size-up to dispatch. The IC provides an operational briefing to the rappellers, and they engage the fire with appropriate tactics. This scenario provided a comprehensive overview of mission planning from the perspective of a Rappel module. Mission planning is a crucial step before engaging in any operation for every wildland fire resource, regardless of module type, size, or capability. While the tools, procedures, and technical expertise vary for each operation, core concepts of mission planning always apply. What is the mission planning process for your module?